Let's go and analyze this problem from our perspective. So, if we look closely, both forces they got certain inclination. That means they're not necessarily going to the right or to the left. They're going right and up for the force in the lower part and left and down for the force in the upper section. That means that with that certain inclination, we get components. We get a components of the force of 20 Newton that goes down like this, and we get another component that goes to the left like that. For the force in the lower part, we get the same, a component that goes up, and another component that goes to the right. So we could decompose these forces F into Fx and Fy. Fy, the one that goes up and down, Fx, the one that goes side to side. If that's the case, we can replace the system by a set of four forces instead of having two. Why is that relevant? Well, force Y that goes down is going to be exactly the same as force Y that goes up. They are parallel and they get different senses. That means they too create one couple. So if we wanted to obtain the moment of that couple, that would be the forces times the distance between them two, or between their lines of action. That means this distance. We can call that distance 1. Secondly, we got the force Fx that goes to the left and the force Fx that goes to the right. They got the same magnitude, they are parallel, and they go in different senses. That means if I wanted to obtain the moment of that other couple, I would need the distance between their action lines. That would be called distance 2. So instead of trying to look for a one single perpendicular distance to both 20 newtons forces, we can decompose them, and we already have distances between point A and B given in terms of, and C, sorry, given in terms of meters in X and Y. So let's go and find the magnitude of force Y and force X. Force Y, force X are going to be equal to 20 newtons times for the force Y, since the angle is about the X, we're going to have it times cosine of 30 degrees. And for X, sorry, sine. And for X, we're going to have cosine of 30 degrees. It's just a matter to calculate the magnitude of these two components. That for the force Y is going to be 20 sine of 30. That's going to give me 10 newtons. For the Fx, we're going to have 20 cosine of 30. That's going to give me 17.32 newtons. There we got the forces we're going to use for the moment. So we're going to have two moments, moment 1, moment 2. Moment 1 is going to be composed by the force Y times distance 1. So distance 1 times force Y. Moment 2 is going to be composed by force X's and distance 2. Distance 2, force in X. Knowing that, We calculate distance 1 and distance 2. Distance 1 is going to be the distance from here to here. That will include 5 meters, 2 meters, and 6 meters. We know that's going to be 13. So we're going to multiply 13 meters times force y. And force y, it's going to be 10. 10 newtons. For the moment 2, we gotta work with the distance 2. Distance 2 is going to be this distance. That will include 3 and 6. That means we'll have 9 meters times 17.32 newtons. Now, what is going to be the sense? From the beginning, looking at the direction of the original forces, we can see they're going to have a direction of the turn or the rotation counterclock. That means positive. However, does it apply to the same in the components? Well, yes. If we look, the components that work for the force y, the one on the left is going down, the one on the right is going up. That means they're going to rotate counterclock. If we look at the components in X, the one in the upper part goes left, the one in the lower part goes right. That means we're going to have also a counterclock rotation. So from there, we just calculate the magnitudes of the moments and add them together to get the magnitude of the total moment. For the moment 1, we will have 13 times 10, 130 newtons meters. For the moment 2, we will have 9 times 17.32, which is going to be 155.88 newtons meters. Both positive, making a turn counterclock. That means the total moment is going to be 130 plus 155.88 newtons meters. That will deliver 285.88 newtons meters in a counterclock direction. That's going to be the answer. And if you look, it's pretty much exactly the same as the answer that we obtained from the last meter. Only that here we only decompose the forces and look for the distances that we already were given.